Yeah, hi, it's Mr. Kane here, and a little video clip talking about some of the terms we're going to meet when we're dealing with solutions and dissolving stuff. So let's see what things we're going to meet. So we've learned a little bit about solutions already. We meant that that's the name they give to these homogeneous mixtures. Things that are the same wherever you look in the mixture. Glass of sugar and dissolved in water, it's the same wherever you go. So they can be gases, liquids or solids, so solutions made of all these things. So as I said before, examples, sugar and water. So spoonful of sugar going into the water and stir it in, and it dissolves and we make a solution. So common things you're going to meet. So you're going to have solutions of gases dissolved in gases. So we've got the air around us, carbon dioxide, oxygen, nitrogen, and a heap of some others making up the air. Liquid dissolved in gas. We've got the water vapour in the air around us. A gas dissolved in liquid. That carbon dioxide that fizzes out when you open your fizzy drink. Liquid dissolved into a liquid. Vinegar is an example of an acid, acetic acid dissolved in water. A solid dissolved into a liquid. Salt or sugar into water, so the seawater or the sugar into your cup of tea. Solids dissolved in solids. Most silver jewellery is actually a blend of copper in the silver, and we also have solid and solid when we make gold jewellery as well. There's copper blended in with that just to make it more durable. So what are some of the terms that we're going to meet? So we've met solution already. It's just a homogeneous mixture. It's the same wherever it is, and there's some fancy words there about the size of particles you'll find in that, but they're really small in a solution. We've got things actually right down at the molecular level, dissolved apart. A solute, that's the stuff that's being dissolved. So that's like the sugar in the water, the stuff that's actually being dissolved. And the solvent is the thing that's doing the dissolving. It's the solvent. So it's when we use a solvent, we take things apart. It dissolves things. What other special terms we're going to meet? A colloid. Milk is probably the most common. It's not technically a solution because it's containing particles that are bigger than molecules, and it has some other effects as we'll see shortly. But it's homogeneous. It's the same wherever you go. And milk will be the most common one that we'll meet with that one for a colloid. And a suspension, so muddy water is a typical one here. It looks like a solution, but you leave it for long enough and it's got big particles and they'll separate out and slowly sink to the bottom. So bucket of muddy water from the river and leave it to stand overnight, and all the mud will settle to the bottom and you'll be left with the water on top that could be quite drinkable. So as I said, they have different properties. So solutions, nothing's going to settle out of a solution, but with a suspension it will settle out. Solutions will go through filter paper, colloids will, suspensions won't. That's why we can use filters to clean out water in places. A membrane, a cell membrane. So solutions go through that, colloid suspensions won't. Scattering light. Your glass of sugar dissolved into the water, you'll see through it. You hold up the light and you can see through it. It's not scattering the light, whereas milk, it looks white. The light is being scattered everywhere. Muddy water has that brown colour. It's scattering the light. And then we get this thing called colligative properties. I didn't know what that was, so I had to go look it up. It was quite interesting. So if you want to go find out more about colligative properties, do what I did. Google it. More terms. So saturated. Sounds what it is. You can't dissolve anything more. It's saturated. When you're soaking wet and you're saturated, you can't get any wetter. So if a solution is saturated, then we can't dissolve anything more into it. Unsaturated, of course, you're still a bit dry perhaps if you're unsaturated. Same with the solution. It's unsaturated when we can dissolve a little bit more into it. And some more. This is an unusual one, supersaturated. If we dissolve stuff into the solvent, at a higher temperature, then we can usually dissolve a bit more. Then when it cools down and it doesn't crystallize, we'll talk about that later on, we get a supersaturated solution. When we start making copper sulfate crystals, we often try and get a supersaturated solution. But it's not easy to do, but it can happen that we get more dissolved in there than we probably should. Miscible. So two liquids soluble together, they're called miscible. So vinegar, that acetic acid and water was an example of that before. They dissolve together, and of course we've got the opposite of that, which is immiscible. So oil and water, they don't mix, one floats on top of the other, they're immiscible. Solubility does some funny things, as we mentioned. Okay, so how much is required to get to a saturated solution is called the solute solubility. So some things are more soluble than others, and temperature affects that mostly. We all know we should know that you can dissolve more things into a hot stuff than cold stuff. So yeah, most things increase with temperature, their solubility. For example, here's some common things you dissolve into water. Glucose, yep, we all know we can dissolve more sugar in a hot cup of tea. Intriguing thing here is copper sulfate. It's just so copper sulfate here, okay, it increases as temperature goes, but not as much as the glucose one does. And the other one that's quite interesting to note is salt. Okay, when you're trying to dissolve salt into hot water, it's not going to make much difference. As we can see, as the temperature increases, the solubility only goes up by a small amount, okay, a little tiny amount here. Whereas glucose, you can dissolve heaps. So that's solid stuff going into water. The interesting thing is gases. Most gases, they dissolve less when the temperature goes up. So here we go is a graph of some of the common ones, and main one here we're looking at oxygen. Okay, oxygen, not much dissolves anyway, which is why fish's gills need to work so well, but as the temperature goes up, even less goes into the water. Okay, which is why when the rivers get hot, the fishes go down deep where it's cold and they can have more oxygen in the water. And look at the carbon dioxide graph. Okay, when water's cold, you can dissolve quite a lot into that. As it warms up, a lot less goes in. Now that's going to have some effects as global warming takes hold. There'll be less carbon dioxide be able to be dissolved in their oceans, more in the atmosphere, making the greenhouse work, making the oceans warm up, causing more carbon dioxide to come out of solution, and so on. A bit of a vicious cycle going to happen there. Pressure will help things. We got you can dissolve more gases under pressure, which is why when you're looking at your fizzy bottle, it's all, you can't see any gas in there. Open the lid, you release the pressure, and it starts to bubble as the gas comes out of it as the pressure drops. And here's a little picture of what happens when sodium chloride, which is salt, dissolves in water. Down the bottom part here we've got the green being the chlorine atoms and the white being the sodium atoms. Sodium has a little positive charge on it, chlorine a negative, which is why they sort of hang out together. When they go into water, they separate, and we have little clusters being made here. Here's a cluster of water molecules around the sodium, and we can see this part of the water molecule, okay, the oxygen part, going closer to the sodium part, okay, just with the way the charges work. Here's a cluster forming around the chlorine atom, and we've got the hydrogen on the water molecules being closer to that. Just using the charges to get them close together. So that's how it actually all works when it dissolves. And then when it stops dissolving, we get crystals. So it starts to dry up, we get crystals forming. That's called crystallization. So we'll make some crystals later on in science using copper sulfate. but we'll see that, you see that happening when they're making salt in various places. They can make it here in New Zealand, a place called Lake Grasmere, big ponds of seawater slowly drying out, and then when the water goes, we're left with salt that we use for our food. And we can get crystals in other ways as well. So when things get really cold, so for example water freezes, we get crystals forming there. So there's some crystals like that in the old snowflake. Okay, and that's us done. Thank you very much for watching. I hope it was helpful and you're familiar with some of the terms now when we start to meet them in science.